Hello, how the tech are you? We have a tech and great show. I'm not asking anybody how the tech they're doing on the show because we've killed that joke. Anyways, this is our weekly tech show on Echoplex Media. We talk about tech news and pretty much anything we feel like talking about in tech and related subjects and science. We do some science. Science is good. I am historian Matt, and I usually talk about some news stuff, and I do have a little bit of science news, but I'm also teaching HK how to program in a real language, that one called Lisp. And I've got Learn to Lisp Part 3 on my docket for today. So what I'm covering for today, first part is Monkeypox. We got an update on the Monkeypox virus and what's going on there. Not a whole lot. It'll be a short one, but there's been some changes recently, so I want to cover that again. And then, as I said, Learn to Lisp Part 3, and it is called Listomania. We're going to be talking about lists. So, the guy with the pink mic.
I'm HK Perrin, and I am a software engineer, so I like to cover software engineering news. I will also cover system administration news, which is not the same thing as software engineering. And speaking of that, I have some sysadmin news related to the best programming language, far better than Lisp. WordPress 6, which is written in PHP, the best programming language. WordPress 6 came out recently, so I'm going to talk about that. And I'm going to talk about Electron 19, which is something that's actually written in a really good language. Well, I guess Electron is half written in C and half written in JavaScript, so both are great languages. But yeah, I'm going to talk about Electron 19, and then over to Dave.
So I just got two stories this week. I got a Gnome Shell. It's going to be working on a mobile device maybe sooner than you think. There's it's called Fosh, and they got it working on a Pine phone. HK probably thinks that's interesting. And then New York State passed the first real right to repair bill. So we're going to talk about the right to repair and your devices. So
this is my Pine phone. It's the Manjaro edition.
So I believe Matt is first. So take it away.
Yep. Let me get my slideshow up and going. So I'm going to be talking about, this is not what I'm going to talk about first. I'm going to talk about Monkeypox first, not Learn to Lisp. So first thing on Monkeypox, it's been spreading, unfortunately. And in the US, the US is monitoring about 400 people who may have been exposed to Monkeypox. We have 21 confirmed cases across 11 states. So that's significantly more than we had before. We only had a few cases before, and now we're up to 21. And 400 people we're tracking to make sure that they don't actually develop it. So they were exposed at some point. I don't think any of them have been confirmed yet. Luckily, there's been no deaths in the U.S. yet for Monkeypox, but it's possible. We don't really have enough cases, and the cases increase. It has about a 1% death rate, and we could start seeing deaths. And I really hope we don't get to that point, and that we can actually stop it. Any questions on that part before I go on to transmission?
I just think it would be really ironic if, like, not only have the millennials been hit with multiple once-in-a-lifetime financial crises, but if they're also hit with multiple once-in-a-lifetime pandemics.
Yeah, that would be pretty crazy. Although I want to point out that most financial crises are once-in-a-lifetime financial crises because they're different every time, if that makes sense. It's usually something else that's causing a problem every time. Most of the time, we actually fix what the problem was after the fact. We didn't do a great job this last time. Anyways, we're not talking about financial crises. We're talking about Monkeypox. And quickly, I want to cover for transmission. It is transmitted human to human through close contact, like skin to skin contact. And it is possible for a respiratory transmission if you've, had prolonged face-to-face contact with somebody with monkeypox. There seems to be some rumors going around that it is sexually transmitted, and that's not really correct. I mean, you can get it through sex, but it's the close contact, the skin to skin contact in prolonged face-to-face contact that's actually doing the transmission. So be careful out there. Hopefully we can actually stop this one before it gets started. It doesn't seem to spread as well as COVID-19, so we could get lucky there.
So what you're saying is if you're going to have sex, don't be face to face?
Well, no, because you're still touching.
Are you telling me that members of the Congress have been lying about monkeypox being transmitted specifically through gay sex?
Have they been? I haven't actually been following that, but I have heard rumors that some people have been spreading that lie.
Yeah, members of Congress. Again.
Oh, good. I should have known.
We learned about it last night. Fun times.
Yeah. Yeah, and I wanted to say that it's not specifically sexually transmitted because your usual methods of safe sex is not really going to help because it's not transmitting that way.
Right, transmitting from the skin to skin contact, like your arm.
Yeah.
Or whatever. It's not. Yeah.
Yeah, pretty much.
You should still practice safer sex, though.
Yeah. Exactly.
Full body condom.
Exactly. That's all I got on monkeypox. It's a developing story. I will continue to follow it and give updates, but hopefully I will not have to give up updates for much longer. It doesn't look like it's going that way, unfortunately. I'm going to move on to my second topic, Learn to Lisp Part 3, Listomania. So Listomania, I'm going to be talking about lists in Lisp. And that's going to be a little confusing for Lisp and Lisp because that's where the name comes from. But I'm actually not going to talk about lists that much. I'm going to talk about sequences or seq. And that is actually an interface in Clojure. So last week I mentioned that instead of talking about common Lisp, I was going to switch over to Clojure, which is a version of Lisp that runs on the JVM. So this is how Clojure works. It actually has something called an iSeq, which is an interface. And an interface is a Java construct that basically just says, it's not an actual class, it just says, hey, this class implements these functions and stuff and has this stuff on it. So it can be applied to pretty much any object in Java. And because Clojure is based on Java, that's where it comes from. You can actually implement interfaces in Clojure too. It's a little bit funky, but this is where the basis comes from. Common Lisp, I'm pretty sure, does something very similar, but not exactly the same. But basically, what you have to do for an iSeq is implement these three functions. The functions are first, rest, and cons. So I've already talked about first and rest. I'm going to cover a little bit of first again in this talk, but I've not talked about cons. So I'm going to go on to that. But real quick, first pulls out the first item, and I have a collection here because that's what it actually, or COLL, that's what it has in the docs for Clojure, but it's any seq basically, which is seq is basically something that implements iSeq. So first on a seq will return the first thing, first item in that seq. Rest returns everything but the first item in the seq. And then cons, which is the new one, takes an item and the seq or collection. And cons will add the item to the beginning of the given seq. So with these three items, we can add and remove basically items to the seq. And
does it stand for
step through it.
consolidate?
What was that?
Does it stand for consolidate?
Cons, I think for construct.
Oh, okay.
Yeah. So yeah, I think con stands for construct because you're adding an item and basically that's how you could construct an entire seek by just adding items one after the other at the beginning. So I think the first thing I have after that is real quick. I'm showing some examples of cons. So the first one I have it's actually a list that has numbers 2, 3, 4, and 5 in it. We're going to cons 1 to it. So passing it to cons, you have the number I'm going to add first, so 1, and then the list. Of course, you can add anything to a list. I'm just using numbers for examples. So cons 1 to the list 2, 3, 4, 5, you end up with a list containing 1, 2, 3, 4, 5 in that order. And then the second version I have is the same thing, except instead of a list, I'm using a vector that contains 2, 3, 4, 5. And this is kind of important because when you cons the number 1 onto the vector 2, 3, 4, 5, you don't end up with another vector. You end up with effectively a list. It's a seek, and I'm sure internally it's not exactly a list, but it looks like a list. It is not the original vector. That's the important part. And contains 1, 2, 3, 4, 5 in that order. And then quickly at the end, I've added some special cases. So consing 1 into an empty list will obviously just return a list containing 1. And then the kind of confusing one is consing 1 into nil gives you a list containing 1. And I'm sure you're wondering what nil is because we haven't covered that yet. Any questions, HK?
No.
Okay. The nil is null. It's comes from Lisp back in the early days of Lisp. For some reason, they decided to call null nil. Don't know all the details of that reason, but it continues all the way into closure. So it is exactly the same. Nil is just the what was it called? The symbol that we use for null. If you pass nil into something that's in like a Java side, so because you can talk to Java from closure, nils will become nulls and vice versa. So pretty straightforward there. But I wanted to mention it since I haven't mentioned it before. So another version another function that's very similar to cons and it can get confusing is one called conj, C-O-N-J. I think that's short for conjoin. And that works a little different from cons. I wanted to mention and go over it real quick. So the first obvious difference is for conj, the function conj, you have your seek first, and then you have the item to add to it. And I didn't show it on the slide, but you can actually add multiple items and it'll just do it one at a time. And the big difference between conj and cons is it'll return the same type that's passed in, I think for pretty much every version. So every type of seek you pass in will return the same type, but where it actually adds the items depends on the type of seek. So if it's a list, it's easiest to add stuff to the beginning of a list. So if you conj the list 2, 3, 4, 5 and add 1 with conj, it'll put the 1 at the beginning of the list and you end up with a list 1, 2, 3, 4, 5. But a vector is different. So if you conj 1 to the vector containing 2, 3, 4, 5, it's actually easier to add stuff to the end of a vector. So that returns a new vector with 1 at the end. So it's 2, 3, 4, 5, 1. And then just for funsies, I put in conjing 1 to nil, which returns a list containing 1. So that's a little conversion. That's kind of funny why you're doing nil like that, but that can be helpful in the future, and it ends up avoiding some null pointers. But in a lot of cases, nil is used as the empty set or something that makes sense for that location or for that type. If that makes any sense. I don't know. It tries not to throw exceptions.
Now, by by easier, saying it's easier to put something at the beginning of a list or the end of a vector, you're talking about time complexity, right?
Yes.
Meaning, like it is that operation, adding something to the beginning of a linked list is an O of 1 operation, meaning it takes the same amount of time whether you've got one thing in the list or whether you've got a million things in the list.
Correct.
Whereas adding it to the end of the list it'll take more time as more things are added to the list.
Well, except that a vector is kind of like internally an array. And I think what it's doing when you add multiple items, it's basically like internally there's like multiple arrays. So it can be pretty close to O of 1, or it's probably O of the number of items that you added in. You're adding to the vector.
Yeah, I think with Java, because this is based on the JVM, so I think internally increasing the size of an array is an O of 1 operation.
It's increasing the size of an array list but that's not an array. I don't think you can do that. I don't think it's, well, yeah, it is O of n. Yeah. Anyways. But this is not Java, but it is, I think, internally using an array. But it's all, but remember, a vector is immutable. So you get some advantages of having an immutable object and just like changing around interfaces and stuff, if that makes any sense. I don't know all the details on why that's faster, but that's what it does. Okay?
It's very strange behavior.
And it can be confusing. And conj is kind of preferred for adding stuff to seek sometimes, unless you specifically want to add it to the beginning. So it can have some unexpected behavior if you're not aware of what's going on. So moving on, I wanted to just cover, so once we have a seek, we want to get stuff out of it. So I just wanted to cover some simple functions. There's a lot more. But this one is just getting one item from a seek. And in this case, the seek I'm using is vectors because they're easy to throw in here. But as I mentioned, we have the first function, which returns the first item of a given seek. So in this case, I have the vector 1, 2, 3, 4, 5. I want to get the first item. That is, of course, 1. And of course, they're going to have a function called second, which will get the second item. And so I'm passing second the vector 1, 2, 3, 4, 5, and of course returns 2. But they didn't want to make a name for every single other position in a seek. So they came up with another function called nth, which returns, well, the nth item in a seek. And my example here, I'm passing the vector 1, 2, 3, 4, 5, and the number 2 as the item I want to get out of it. Or the position I want of the item that I want to get out of it. In this case, so nth is 0 based. So the first item in the vector is at position 0 and the second at 1 and so forth. So passing 2 means I actually get the number 3 from the vector.
Yeah, I think that's
that?
confusing. That's confusing because, like, if you pass a 2 into nth, shouldn't it be second? But it's
you would
not
think
second.
That would be second.
It's the second position.
Well, the second position
of a 0 indexed
is really
position.
1, right?
Yeah, I think the words are just confusing. You know,
they are
first, second,
confusing.
and then nth isn't actually. It doesn't directly translate to the number that you pass to it.
Right. Yeah, it's kind of weird because in this case, they switched to 0 based, which is really common in programming to be 0 based index. But it seems like first and second aren't, but they're really just words. And for the most part, this is not a problem. I almost never use second. First is pretty common because of certain sort of idiomatic things you do in Clojure and Lisp, but and nth happens occasionally, but again, you really don't want to like pull out a random number from definitely from a list because you have to step through the whole list. Vector, it's a little better. But it is something you use sometimes. So after doing first, second, and nth, we got some other stuff we probably want to do with seeks in general. So this, as I said, I'm passing a vector here, but this works for anything that implements iseek. So the next thing we have some more functions for doing that. What if we want to take some number? So this is basically taking the first n items in a seek of some sort. So the function take takes two arguments. One is the number of items to take, and the second one is the seek you want to take. So my first example, I want to take 3 from the vector 1, 2, 3, 4, 5. And that returns a new list. It's probably a seek, but a list that just contains 1, 2, 3, because those are the first 3 items in that vector. My second example is basically trying to take more than the number of items that are actually in the seek. So in that case, I want to take 6 from the vector containing 1, 2, 3, 4, 5. The vector 1, 2, 3, 4, 5 does not have 6 items, so we just return a new list containing 1, 2, 3, 4, 5. Notice it's changed from vector to list here. Pretty straightforward. Any questions?
Nope.
So if we want to take some number of items, one other thing we might want to do is drop. So drop skips some number and then returns the rest. So my first example, I'm dropping 2 from the vector 1, 2, 3, 4, 5. So that's the arguments for a drop. Is the first argument is the number that I want to drop, and the second argument is the seek I want to drop from. So in this case, I want to drop 2 from the vector 1, 2, 3, 4, 5, and that will return, instead of a vector, again, it's converting it to a list, and the list contains 3, 4, and 5. So it just skips that first 2. Now, there's some special handling. Obviously, like if you want to drop 0, that means it's not going to make any change. So it's just going to return the original items. But in my example here, drop 0 of the vector 1, 2, 3, 4, 5 will return a list containing 1, 2, 3, 4, 5. And it also handles negative numbers by basically ignoring them. And in the case here, I'm dropping -2 from the vector 1, 2, 3, 4, 5. Ends up with the list 1, 2, 3, 4, 5. Any questions? No, it doesn't sound like it. So with take and drop, you can basically use them to take a subsequence, of whatever seeks that's passed in if you do it right. And it can be useful for other things. So after these functions, I want to cover a pretty special function we probably don't use it very often, but it illustrates something pretty interesting with the way that seeks are implemented. I think I have this next. So I'm going to talk about range. And I'm sure you've seen range before. And I promise you, I'm almost done with this. Range is a function that it will take a variable number of arguments, and we'll talk about that. But this first version of range that I have takes 3 arguments. The first argument is the start number. The second number is the end. The first number the start is inclusive. The end is exclusive. So it doesn't necessarily include the last number. And then the third number that's passed in is the step. So this is a way of generating a sequence of numbers in a range, and with stepping through whatever numbers you want. So in this case, I have a range 1, 10, 2. So it starts at 1, ends before 10, and skips every other one by stepping 2 at a time. The resulting list is 1, 3, 5, 7, and 9. Pretty straightforward here. And of course, if we change this call a little bit, and let's say we drop the step, the number 2, and so we just do range 1 to 10, that's pretty obviously is just going to return a list that just includes 1, 2, 3, 4, 5, 6, 7, 8, and 9. 10 is not included. And of course, the step is assumed to be 1 for these numbers. So that's pretty straightforward. So let's drop another number and see what happens. But we don't want to drop the 10. So we're going to drop the start and just assume the start. So we have range of 10 is going to go through from, it's going to return a list that starts at 0 instead of 1 this time and goes to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Any questions so far?
I do have a question, actually.
What?
What if your step is 0?
I have no idea what would happen if your step is 0. It'll either cause like an infinite loop because it doesn't ever step, or throw an exception, or ignore it because it's an invalid step and decide to do something else. I believe your start and end can be negative. If they're in the opposite direction, I don't know. So if your start is after your end, there's a higher number than your end, I don't know if it'll actually run it backwards or not. But each number could be negative. So far, so good?
Have you heard the joke about the QA engineer?
No.
A QA engineer walks into a bar, orders a beer, orders 0 beers, orders 10 beers, orders infinity beers, orders -1 beers, orders a cat. The first real customer comes into the bar, asks where the bathroom is, and the bar bursts into flames.
I haven't heard that version of it with the real customer, but that's great. I have heard the other one. So we've done 3 different versions of range. What do you think is next?
Is there a 4th version of range?
Yes, there is. And that version is no arguments. And this actually works. And what that is, if you call range without any arguments, it's going to return a list that includes all numbers starting at 0, all integers starting at 0 and incrementing from there. And it does not blow up. It does not cause an exception. And the reason is
dynamically generated.
It is lazy generated. It's it creates what's called a lazy list or lazy seek. And so it'll only actually give you the number when you ask for it. You start, because remember, you pretty much just start at the beginning, right? And step through. You generally don't go to a random part unless you like call drop or something, which can step you ahead. But it's basically not going to generate the numbers until you actually ask for it. And as long as you don't hold on to the head of the list, it will just, as you consume the numbers, it will just drop out of memory as well through proper memory management. So
in JavaScript, there is something very similar called a generator.
Yeah. So there's a number of functions that actually do this. I just like range because it's funny that there's one version that's an infinite and usually kind of surprises people. But there's a number of other functions that do it. You don't have to do it very often. And sometimes you do something similar and it's not actually infinite, but what you end up doing is you use this other function called lazy seek. And this is how you actually make one of these lazy sequences. But lazy seek is a function. It creates a new seek, but does not actually instantiate all the elements until they're needed. To work correctly, you need to really use it in another function. And I'll show that in a minute. And of course, if you screw it up, you can very easily create an infinite loop. When I was testing some of this stuff, I did create an infinite loop or two. But here's a quick example. This is my last thing on Clojure and Lisp, but I'm defining a function. I was going to try to do range, but it doesn't quite work the same way as range. So I made this function called infinite range, and it has 2 versions. One where it takes no values, no parameters at all, and another one that takes a parameter, and that's necessary for the actual lazy seek call. So the first version that takes no parameters basically just calls itself and, adds the parameter starting with 0. And the second version, the first thing it does, well, you have to read these kind of backwards, right? So internally, the first thing is it's calling this increment function. That's the function all the way to the right there. And the inc function basically just increments it. It adds 1 to the value being passed in. And then that value is being passed recursively back to infinite range. So it gets the rest. That combined basically says, get the rest of the sequence starting at the next number that's being passed in. N is the argument being passed in. And then we want to cons n to the rest, basically, of this sequence. So we have cons n, and then the function infinite range, and then inside that inc n. Now, if we did just that, that would cause an infinite loop, and it would just keep creating this sequence that's longer and longer and longer. But we don't want to do that. We add in lazy seek in front of all of that. And what that does is lazy seek, it returns the interface iSeek, but doesn't actually call its body, doesn't call any of the functions in its body until something is one of the functions on that the iSeek is called, basically. So it instantiates the value. So in the body of lazy seek, basically the parameters passed into the lazy seek has to return another seek, basically, because that's what's going to end up being used when it's actually instantiated. And of course, I have an example of this down here at the bottom. We're calling infinite range without any values, but I don't want to just do that because I want to show what it does. So I take the first 10, and it returns a list containing 1, 2, 3, 4, 5, 6, 7, 8, and 9. So you'll notice take actually does instantiate the list the sequence that's given to it, and gets the first numbers.
Could you start it at negative infinity?
Could I start it at negative infinity? I don't think so, because of the way cons work.
Well, I don't think you can because of the way increment works. What is negative infinity plus 1?
Yeah.
Just also negative infinity.
Right. Yeah, that wouldn't work. So no. No, I was thinking maybe if you use conj and then use vectors instead of sequences, because then it would add it backwards, but I don't think that would quite work, right? That makes sense.
You'd call first and it would just blow up.
I mean, on the other hand, what you can do is use the other function called dec and start at 0 and go to negative infinity.
Yeah, but that's not
as fun.
I want an all-inclusive range that includes all integers.
Yeah. So that was my attempt at blowing your mind again. So you can make infinite sequences in Lisp, and it just works.
Yeah. You can do the same thing in JavaScript. Just letting you know.
I think Java now supports it somehow. I know they have streams, but they totally messed that up. But that's all I got for this. So I'm going to go ahead and shut down my slideshow.
The way you do it in JavaScript looks a lot less elegant than that one.
Yeah. It's pretty straightforward. So I said you can do it to make infinite lists like that using lazy seek, but sometimes you use lazy seek for something that's not infinite. For example, you want to make a list from something you're reading off the hard drive, like from a file or something. You may want to use lazy seek so that you're not actually reading from the file until you actually want something, right?
Yeah, and in that way it kind of works like a stream.
Yeah, exactly.
Right? Where you're essentially buffering data into the stream and then reading
so
it out.
Actually, in Clojure, not only do you pretty much use the lists like streams, but I believe streams do implement iSeek and are a list, and you can consume them the same way.
Neat.
There's some weirdness, like the different way you use streams in Java, but yeah, you can do that. Because you can do stuff like if it's a byte stream, I believe you can wrap it in a reader and either do a list of lines instead of bytes, or you can get like characters out or tokens if you have a reader that tokenizes the stuff.
Okay. That's cool.
Cool. So I guess you're up, right?
Yeah. It's kind of like chunked encoding in HTTP.
Yeah.
But yeah, so I'm up. My first story is about WordPress 6. In case you don't know, WordPress is a content management system that powers most of the websites on the web. And by most, I don't mean the biggest ones. I just mean like most in terms of sheer numbers. WordPress has, what is it, like millions of websites are powered by WordPress.
Yeah. Everybody who has their like little website for their whatever hobby uses WordPress.
Yeah, my company website is a WordPress website. And this release is all about themes, or at least you'd think it was reading the first half of this post from them. There were tons of improvements to theming in this version. So themes got an especially good workover in this version. And then another pretty notable new feature is there's a new thing called page patterns, which are essentially just templates. So like if you're creating an About Us page, which pretty much everyone has, you'd use the About Us pattern. So yeah, I'm surprised to learn that WordPress didn't have page templates before, but who knew? My next story is about Electron. Electron 19 just came out. Or actually it came out, I think a couple weeks ago, and I missed it, but I'm talking about it now. Electron is an app development platform that uses Node.js and Chromium. So a lot of I think I talked about this when I was mentioning that I was working on an Electron app. A lot of the apps you probably use and love are written in Electron. Some big notable ones are VS Code is written in Electron. You've got Discord written in Electron. The Spotify app is written in Electron. But yeah, so Electron 19 is not a huge release, but it does. It is now based on Chromium 102. So one of the newest releases of Chromium, or I think possibly the newest release of Chromium. And Node.js 16.14.2. So nowhere near the newest release of Node.js, but at least it's Node 16 and not Node 14. So you get a lot of the really nice features of Node 16. And that's, or actually, I do want to talk about something else regarding Electron. So I'm working on an Electron app, and I recently, like today, the day we're recording this, I just started using Electron Builder, and man, it is so cool to just be able to like run one command and have it spit out on the other end a .exe that you just double click it, and it'll give you a warning that it's not signed because I haven't figured that out yet. But then you say, yes, let it change my computer, and bam, your whole app is installed right there. And you can add things like file associations right in your package.json. You can add icons for your app and for the files that are associated with it. It is very cool. Electron Builder is a really powerful piece of software, and so is Electron. So yeah, some big news there. But that's it for me. So pass it over to you, Dave.
All right. I just got a couple things this week. One of them is just going to be real quick because I don't believe in it. So forever, Linux people have been wanting a Linux phone, like not just an Android phone, like a phone that kind of reminds them of their desktop. Well, there's a thing called Phosh, and this article that I have up here from OMG Ubuntu claims that it might be getting close to being something that regular people can use, and I don't really believe it. It says it's coming along nicely, and I just don't believe it. They did get it working on a Pine phone, though, and I know HK has a Pine phone, so...
Wait, is this Phosh or Gnome Shell?
Phosh.
Okay, because Phosh was working on Pine phone.
Yeah, it is.
Oh, okay.
You can see it down here.
Oh, yeah.
But the idea, what people really want is like to be able to just install Linux on whatever phone they have and not have to go buy a specialized piece of hardware. And this is what this project actually hopes one day to do. And I'm not confident, and I'm not buying a Pine phone. So that's not.
I would recommend a Pine phone just because they're super cheap and it's cool to watch the development and be able to like get to play around with it. But I've talked to people who said they daily drive a Pine phone, and I'm like, what the hell's wrong with you? Daily driving this thing would be an absolute nightmare.
Yeah.
As much as I love Linux phones, they are not ready.
So the story that Matt actually gave this to me because Matt had plenty of stuff this week for himself. New York State passes the first real right to repair bill. The governor hasn't signed it yet, but it seems, from what I know about New York State politics, that's a foregone conclusion. The governor's going to sign this one, and it's going to require device manufacturers to share tools, diagnostic information, and other things that'll help people repair their devices. And I think that's really, really good. I imagine it's not going to be a perfect bill. I imagine there's going to be some problems with it, and it's not going to work exactly like it should, but it's the first one, and it's a big state, big, powerful state. And so I think that's, better than it being like a less big and less powerful state, because if it's written well, these companies are just going to have to make their devices repairable across the country to comply with New York, because they're not going to make a New York version. That's stupid. So this is big news here. Yeah. I'm super excited about this.
But they might only make the parts available within New York.
I think the bill was written so that you had to make manuals, and including repair manuals, available. Do you remember what the limitations are? Did you write them down? I think a big limitation that I think is going to piss off a lot of people, or a particular group, is it was not going to apply to agricultural devices.
Oh, that's where that's one of those things too, where like city folk and country folk were able to come together on some policy that we care about. Because there's why they should be able to repair their tractors. So this is like this is like consumer electronics mostly, or this is a consumer electronics focused bill.
Yeah, and that was like there was a big push because particularly John Deere was starting to add stuff to keep people from being able to repair their own tractors, and farmers like...
Not starting. They've been doing that for years.
Okay, sorry. So they've been doing it for years. Yeah, you're right. And farmers are getting really pissed off because if their tractor breaks, they're out, in the middle of nowhere, right? They're on a farm. They can't get a repair guy out. And they want to get, they need to get their tractor fixed so they can do farm stuff. They got stuff to do right now. And they used to be able to just repair their tractor, or at least get it running again for now, and then take it to the repair guy to get it properly fixed later or something. And that has been a culture that's been around for a long time. And now more and more they can't do that.
Yeah, there's a lot of great things about technology. This is not one of them.
Right. Yeah. Tractor as a service is not actually good.
Yeah.
No, it's not. Definitely not.
I mean, it's funny to call it that, but that's what it ends up being if you have to keep going back to the company just to do even like simple repairs. I'm sure there are major repairs and overhauls that you need done that you'd want to take to like a certified whatever for, John Deere anyway, because they're going to do it right and it's going to, they're going to warranty it. But for minor repairs, this is just tractor as a service. And it's really disappointing that the bill doesn't cover it, but there's just not a lot of agriculture in New York. So maybe by the time California does one, because there's a lot of agriculture here, maybe it'll be a different right to repair bill that also includes a lot of industrial equipment.
Yeah, I mean, that is a state bill, though. That's not the city bill. And there's a lot more land upstate New York, and there are some farms there. There's a good number of them. Also, that's from memory. I'm pretty sure that's true. I think there's a number of other limitations that were kind of surprising, but I didn't write them down because it wasn't my article.
And it's very consumer electronics focused.
Yeah, I think it's very, very much just consumer electronics.
And that's a fault of it, actually, because there's a whole rest of the ecosystem. But like I said, California is an agricultural powerhouse. So if there was a bill like this in California, the agriculture lobby has a bigger piece of the pie here in California. And so I think any such bill that happens here in California will will surely include agricultural equipment, if not just more broadly, like enterprise equipment or whatever, not just consumer electronics.
Yeah, I mean, actually, there's so much technology in California. Probably more likely to get one that specifically focuses on agriculture and not consumer electronics.
Right.
You know what I mean,
wouldn't be the worst way to do it too, because if these companies have to comply with the New York law, then now they have to comply with the California law. Well, now you got both.
Yeah.
These big states lead the way in a lot of ways. Like almost all the emission standards come from California. For cars, because a car company has no choice, right? California puts in a new emission standard. There's so many people here, and so many people here drive cars that they don't have a choice. And New York City is big for consumer electronics. I bet Apple sells more stuff in their Apple stores in New York City than anywhere else. So.
Yeah.
A lot of people don't realize that 1 in 10 Americans live in California. Like we have 10% of the U.S. population.
Yeah. So no wonder that if you have to comply with California regulation, you might as well just make that the standard for your company.
Yep.
Well, cool. I'm excited for this, even if it's imperfect, because maybe it'll be a rural state that passes a right to repair for farm equipment next. That'd be pretty cool.
Hopefully.
Be pretty cool.
Hopefully this is the beginning of a landslide of these kind of bills.
Yeah.
Right. Because like some of they're like, oh, it's too hard to repair your phone. And it's like, well, if my phone's already broken and then I break it trying to repair it, the same thing's going to happen to me. Like then I have to either buy a new device from you or I take it to you because I screwed up trying to repair it and I pay you the money I was going to pay you in the first place. These right to repairs are like, even if you can't get it fixed, they're like, the company has to help you try.
Yeah.
And I don't think that's unreasonable, because batteries specifically are just like, if your phone's broken and you end up getting rid of it, you just you're getting rid of a lithium ion battery. Whereas if you can fix the screen yourself for very inexpensive, you're not getting rid of that lithium ion battery, and the screen is certainly not going to do as much damage to the environment as that battery.
Yeah, or even if you're like throwing away a perfectly good phone just because the battery doesn't work. And like that's essentially what you do with iPhones now, since they've made it damn near impossible to replace the battery. Like your only option is to pay Apple to replace the battery, which is normally very expensive.
Right, but then they've always got a deal for a loyal customer on a brand new phone.
Yep.
Yeah.
Especially if you can give them your old one with a bad battery as a trade-in.
Yep. And they'll like their salespeople or their repair people are like instructed to try and pressure you to get a new item instead of asking for your old one to be repaired.
Right. Their techs are just salespeople.
Yeah.
Yep.
Well.
Yep. So I like this bill. We need more.
We do need more.
Yes.
We need more. Well, that was the show. I think it was a good show. I think that was tighter than the other ones, maybe. I don't know. Looks like less than 40 minutes.
I went long, but you two went really short, so good.
All right. Well, thank you for watching, and remember to like and subscribe. and turn the bell on and go follow us on the podcatcher apps and go to our website and implement a DDoS attack on it. Try and bring it down.
Speaking of that, which real quick, my website is not on like a $5 WordPress instance, and I dare anybody to try to take it down. You can't take down a Squarespace website. Thanks for watching the show, everybody. Check out everything over at echoplexmedia.com.